When we think about cost, carbon and risk, how do you balance these elements when managing or renewing assets? Steve?
Sure. And actually, I think, Lucy, I'd like to challenge the premise of the question a little bit on this one.
Okay, go on then.
Well, because actually in most cases, there's real alignment and it's not a question about balance. Mm-hmm. That actually intervening on assets, doing the right maintenance, the right renewals, the right enhancements at the right time is the right thing in terms of cost, it's the right thing in terms of carbon, and it's the right thing in terms of risk.
Hello and welcome to WSP's Positive Impact podcast. I'm your host, Lucy Siegle. In this series, we explore the ideas, innovations and voices shaping a more sustainable, resilient and future-ready world. Today, we're talking about ageing infrastructure. From roads and railways to water networks and public buildings, much of the UK's infrastructure is nearing the end of its original design life, and in some cases has already passed it. Now, at a time of limited budgets and increasing demands, how do we maintain safety, plan for renewals, and make sure we're future-proofing what we've already built? Well, joining me are two brilliant guests with real insight into this challenge. Steve Denton, Managing Director of Civil Engineering Unit at WSP and currently Vice President of the Royal Academy of Engineering, and Professor Andrew McNaughton, Chair, Network Rail High Speed Limited. Welcome to you both. I think we've got a lot to talk about, so I'm not going to hang around. You'll be glad to know. Let's talk first about why ageing infrastructure is such a pressing issue right now at the moment. Steve, let's start with you.
Sure. And look, I think the place we need to start is naturally as engineers, we'll talk about the roads and the bridges and the assets. But actually what's central to this is the function that those assets fulfill. Mm-hmm. So when we get up in the morning, we turn on the light switch, the lights come on, we turn on the tap, the water comes out. The transportation networks that we've got enable us to travel around the country. Essentially, these assets provide the hard wiring of our country. It underpins how our society functions. It's critical to our economy. So that's the essence of what we're talking about is those assets that fulfill that function. The reason we've got a challenge now with aging infrastructure is really three things that drive this. The first is the age profile of those assets. So when we look at those assets, as you've already said in the introduction, we've got a significant proportion of those that are getting towards the end of their useful life. And we know from, if we buy a new car or a new house that initially they don't need too much looking after. But when things reach a certain age, they just need significantly more looking after. And that's the situation with a lot of our assets. Yeah. But we have to couple that with two other things. The second is that climate change is increasing the pressures on our asset base. And the third is around societal needs and expectations. And you put those three together, and we really do have a significant challenge. And in the context, again, as you've introduced, of limited and scarce resources, that's the circle that we need to square.
Yes, we do have a lot to talk about, don't we? Andrew, I'll come to you.
Well, Steve has introduced it, I think, quite nicely. Remember that we talk a lot about 2050, 25 years' time. Nearly every asset that we've got in use today will need to be in use then. We're just not going, it may have been renewed, but we're not going to build a new civilization. We're reliant on what we've got. What we've got, we never know enough about. If you build new, as many engineers do, you talk about factors of safety. When you're talking about old infrastructure that's been built many, many decades ago, you're largely talking about a factor of uncertainty. You don't know really how it was built. You don't know how it's being maintained, but you're making judgments about its use just now, next week, next month, next year, next decade. And these are really challenging issues.
Yeah, I hadn't actually even thought about that. But yes, how do you have the back history of all the materials and the processes and all the rest of it? Wow. Okay, well, what does good asset management look like in practice, and what does it take to get it right? I'd really be interested to hear about other examples from around the world that we can draw on here as well. Andrew, I'll come to you first. So good asset management.
Sometimes it's knowing how much you don't know about things.
Mm-hmm.
It was once described to me in my years managing today's railways, which this year are celebrating 200 years. 200 years. But almost everything that was built 200 years, the foundations, the earthworks, the tunnels, were built then. They're there forever. Or at least we're managing on a basis of, we're not just seeing them to the end of their life. Their life has to continue. As an engineer, you are always thinking, what don't I know? What do I know? But the big prize is, with the amount of money you've got, is not deciding what to do with something. The biggest prize is deciding you don't need to do something with it. That is the cheapest engineering solution, is to not do something.
I suppose it's how you get to that point, but maybe we'll discuss that in greater detail. Steve?
Yeah, look, building on what Andrew said, I mean, the essence of asset management is about decision making. Mm-hmm. And fundamentally, when you're managing existing assets, there are kind of three questions you're confronted with. What's the optimal intervention to make? When's the right time to do it? And crucially, how do I build a compelling case to release the resources to be able to do that? And I think that, for me, the essence of good asset management is firstly making sure that we frame those questions in a way which returns to what's the purpose, what is this asset seeking to serve? So we get the question right. But then getting into the detail, you need information, you need data, you need to manage the uncertainty that Andrew's talked about. So I think there's a really important part about effective asset management, which is really trying to do everything we can to create that understanding, to be able to make those predictions about how things will be in the future, and to be able to make those timely interventions. Because, again, as Andrew said, we're talking about making decisions today, but about assets that we need to function into the long term.
Mm-hmm. And are there any examples from other countries, other places, where this has been done kind of well or in an interesting way?
Look, I think they certainly are. I think the point that I would make on that is actually, I think here there's lots of good practice.
Yeah.
Those people responsible for managing assets today are facing some quite considerable headwinds, but most of the times things work well. Mm-hmm. And so I think we need to recognize that actually there is an awful lot of good that happens already. Mm-hmm. But we can, if you go around the world, and I mean, Andrew, you'll probably, talk around some rail systems and experiences around the world. Yeah, so you do sense a heightened degree of reliability in other places around the world, but sometimes that's down to different asset profiles, different ages of infrastructure, maybe different local pressures.
Yeah, what do you think, Andrew? Because Switzerland is often mentioned as a good example.
I love Switzerland, and I spend as much of the time as I can there. One of the things that I've learned from my Swiss colleagues, or it's reinforced what the arguments we can make here, is the challenge that leave something as long as you can. Mm-hmm. But when you do intervene well. In other words, don't leave something, then bodge it. If you're going to spend money, do a decent job. Decent job doesn't mean gold-plated and all those sorts of silly words. Mm-hmm. It means knowing that when the time comes to intervene, you want to do something that's then going to last a reasonable time. Reasonable time depends on the business priority, the functional priority. But don't think that managing old assets is about going around with a coat of paint. And that's not what it's about. It's about making real engineering judgments about what is best to do that will then last for a generation or two generations, depending on what it is.
So, Andrew, do you have an example of asset management that you just think is really excellent?
Let me tell you about a job which has won this year's National Rail Awards. It's the reconstruction of a railway embankment on the East Coast Main Line from London to Scotland, just north of Darlington, at a place called Browney, that was built 180 years ago with the techniques of the time and any old material that they could find. It's been slipping constantly for 180 years. But in the last 2 years, a team of people from Network Rail, the consultant, the contractors, have reconstructed that embankment so that it is now takes more traffic than ever, at a higher speed than ever, for the next few decades. And they did that in 2 years without ever a complete reconstruction of the embankment, without ever applying a speed restriction on what is one of the most valuable and heavily used bits of railway in the country. That, to me, was just brilliant asset management. They used techniques which haven't been used before, and they did it because they were absolutely focused on what is the purpose of this railway. Not just what are we trying to achieve as engineers, but they thought about the travelling public, the people who pay the money. And I just thought that was brilliant, which is why it was the winner.
As a non-engineer, could you indulge me a bit, unwrap that a bit? So what sort of decisions might those be? Give me some examples if you can.
One is in a railway context. Mm-hmm. The current railway system has 65,000 embankments. 65,000 embankments. Which of those is not going to withstand the next storm, Amy or whatever? Some won't. When you intervene, do you just go, there's a bank slip that's 10 metres long? Or do you say, look, this 100-metre long embankment is all built in the same way. It just happened to fail at that point. Do we go in and just replace 10 metres? Or when we've turned up with a whole army of civil engineering infrastructure, do we do a more cost-effective job and replace the whole 100 metres? Then we can walk away from it. And we don't need to be thinking, oh, I wonder when the next 10 metres is going. So you're reducing the risk at that point. Mm-hmm. Always making the judgment that you then spent more money there that you're not going to spend somewhere else. Mm-hmm. But if you get into a cycle of just running around like spinning plates, going, I've just spun it enough to keep it going for the next 10 seconds. There's another plate. Then you end up with all the plates dropping on the ground.
Right, which we definitely don't want. Thank you. Thank you for explaining that to me. When we think about cost, carbon and risk, how do you balance these elements when managing or renewing assets? Steve?
Sure. And actually, I think, Lucy, I'd like to challenge the premise of the question a little bit on this one.
Okay, go on then.
Well, because actually in most cases, there's real alignment and it's not a question about balance. Mm-hmm. That actually intervening on assets, doing the right maintenance, the right renewals, the right enhancements at the right time is the right thing in terms of cost, it's the right thing in terms of carbon, and it's the right thing in terms of risk. Mm-hmm. Essentially these things are pulling in the same direction almost always. And actually I'd go further than that when we think about the role that engineers have in decarbonisation, I personally think that probably one of the biggest contributions that we can make is actually to find ways to extend the life of our existing infrastructure. Because there is nothing more wasteful than knocking down and replacing something which with good expertise, good judgment, can have its life extended.
Yeah, that makes a lot of sense to me. Andrew, would you like to reject or accept the premise of the question?
I'm completely with Steve on this. With one slight build, which is when we talk about risk, people immediately think about probably safety risk. Mm. But actually, we're talking as an engineer about safety risk, performance risk to the user, business risk to the owner, financial risk. All these are aspects of risk, and those are what you're balancing. Fundamentally, what Steve said is absolutely right. They are pulling in the right direction. Mm-hmm. If you make the judgment, the engineering judgment, at the optimal time, those things will tend to come together.
Mm-hmm. I'm really thinking about what you just said, actually, Steve, and this is probably more my industry than yours, but in terms of how we communicate decarbonisation, for example, it's often about the new. When I think about what we talk about, so we will message, this is happening, it's being built with this, and this is going to, sequester X amount of carbon or whatever. I mean, we should really be finding a way of messaging longevity in infrastructure.
Oh, absolutely.
Yeah.
Absolutely. Yeah. And one of the challenges actually in that space is that it's tricky to work out exactly how to count it.
Yeah.
Because actually what we're talking about is a kind of carbon avoidance. And actually, when you get into talking about carbon avoidance, it does get quite complicated, and it's possible to present things in ways which are not consistent with actually what you're trying to achieve with decarbonisation. So it's just carbon avoidance is it's a complicated space to communicate in. But I think the central point is absolutely fundamental, and actually, I think in terms of research efforts, focus. Again, we so often think around, what are the opportunities around lower carbon materials? We know where a lot of the debate is.
Yeah.
And I think we failed a little bit in not making sure that debate is balanced against the opportunities from extending existing infrastructure and existing assets. And I think to kind of piggyback something that Andrew said as well, there is brilliant engineering in extending the life of existing infrastructure. Making complex decisions in the context of uncertainty, coming up with solutions that are not just for now, but for the future. That's great engineering. That's real skill. And I think what I found in my career, and I've been in a very privileged position to work on many, many projects, some new design projects, a lot of work on existing infrastructure. I've always found that the most taxing projects, the ones that I felt have kind of plumbed the greatest depths of my engineering ability, have been those dealing with existing infrastructure rather than new.
Well, that leads me very nicely onto my next question, which is about innovation. How do we use innovation to make smarter decisions about infrastructure renewal and to make sure we're future ready?
So I want to talk around digital technologies here, I think in response to that question. And one of the things I'm really excited about is when I think back to the start of my career, I would regularly encounter engineers that had spent their whole careers looking after a particular population of assets. They knew them really well. There was a wonderful spirit of custodianship in what they did. And we've lost some of that. And we've lost some value as a result, because contractual arrangements have changed, people's careers expectations have changed. And I think when I talk to engineers of my generation, there is that sense that over those years we have lost something. What I believe is actually that we can recreate some of the positive attributes that we had from that spirit of custodianship, but we need to do it in a different way.
Right.
And we've been involved in a really interesting concept around digital custodianship, thinking about how we recapture the ability to think about decisions for the long term, to really understand our assets better. Crucially, that when we're making predictions for the future to inform those decisions, we need to understand how things are changing. How can we gather that information and that understanding? And that starts with really good intelligence about our assets. But then it builds from that in terms of using that information to then build machine learning models that help us in terms of diagnosis and prediction. But it starts with good data. How do we gather information from site? How do we use digital tools in the way that we gather information when we're inspecting structures and other assets? And how do we collect that in a manner which unlocks that potential to then apply machine learning techniques to build models, to use those to inform better prediction around the future behavior of individual assets, but then also to think about how we then apply that across populations of assets.
So again, I'm going to ask you to explain that out a little bit for me. So just give me some examples. So I suppose you've got things like drones, so you can get things from all different perspectives. You've got those pingy things. I don't really know what they do, but you tell me a little bit about them.
And whenever you talk about this, everyone kind of goes to drones. There are undoubtedly situations where drones are attractive technologies, but actually you don't really want to be flying drones next to a railway or a live road.
Yes, I guess not.
Actually, what I think is really interesting is drawing a parallel between the way in which we currently inspect assets, which is an important part of the process, as Andrew said, and what happens in medical environments.
Mm-hmm.
So in medical environments, you essentially have experts in imaging. You have AI-supported tools that triage those results. And then you have experts that do the final interpretation. That's different from what we do when we're looking at infrastructure assets, that we send people out on site to look at things, often at night when you can't see things very clearly. At night, in poor weather, and what we capture is what those people write down. Mm-hmm. I think a much more interesting future is a future where we think about the inspection process being an imaging process, not just visual images, but other images as well. In the imaging process, we then use tools to be able to build models and have AI-supported interpretation of what we're seeing. And then we can use that information to inform expert decisions. And if I can just sort of pick out one particular theme here. When we're making a decision, we're of course interested in how things look today.
Mm-hmm.
But actually, we're probably even more interested in what we think they're going to look like tomorrow. Mm-hmm. And one of the best ways of getting a sense of what they're going to look like tomorrow is to be able to look back and see what they looked like yesterday and see how they've changed. And one of the deficiencies in the way that we generally collect information about our assets at the moment is, whilst it gives us a really good sense as a snapshot in time, because of the way that information is collected, it's very hard, even qualitatively, to really understand how things are changing. Mm-hmm. And it's almost impossible to quantitatively understand how things are changing. So one of the things I'm really interested and excited about is actually how we can gather images, photographs of defects particularly, but to be able to overlay images at different points in time and to be able to track how things have changed.
Yes.
And to be able to actually use digital tools to be able to, for example, measure the extent of defects. And so we can really quantify how things are changing.
And I think this all ties together in my next question, which I'm determined to ask, which is what kinds of culture or mindset shifts do we need to move from? So we're moving from, if we think about moving from reactive fixes to this long-term resilience that we're talking about, what do we need to do?
I think as an engineering community, we've long recognized the need to approach the management and maintenance of our assets in a more proactive way. I think sometimes it's felt as though that message hasn't been heard. And I think the reasons why we're talking about it more now is because the age profile of our infrastructure and the challenges around societal expectations and climate change means that we're on something of a burning platform right now. So I think that amongst the engineering fraternity and asset management fraternity, I think these things have been understood for a while. Mm-hmm. I think where the change needs to come, the change I would love to see, is that somehow we need to get to a place where across society, across decision makers, in policy, we stop taking our existing infrastructure for granted. Mm-hmm. We just expect it to work. When I turn on the tap, I expect the water to come out. When I stand on a train platform, I expect the train to arrive. Mm-hmm. That's not a passive state. These things don't happen by accident. They happen because people are making good decisions, good investments, good interventions at the right time to keep our infrastructure functioning. But I think too often we just take that for granted. And so in terms of the cultural shift I'd love to see, it's one where if you're driving down the motorway and you're delayed because there's some cones in the road and there's some maintenance being undertaken, we don't tut and think, well, that's a failure. We look at it and say, okay, that's disrupting me a little bit today, but it's happening so I'm much less disrupted in the future.
Wow, that would be quite the shift, though, wouldn't it?
It would be a shift. It really would be a shift. I travel a huge amount by train. People moan about the trains sometimes not being very reliable. Actually, I find them by and large to be really very reliable. And I rely very heavily upon them.
Mm-hmm.
And when you're disrupted, you are disrupted. But I just think there is such a sense of, we do take this for granted, and we need to recognize that that planned intervention,
Mm-hmm.
planned disruption to undertake maintenance and renewals is so much better than when it's unplanned.
Mm.
And I think we just need to be much more accepting of that.
Yeah, yeah.
I want our engineers to be more curious.
Mm.
Curious for actively looking out for new ideas, new techniques, many of which are in tiny, almost one-person startup companies. People have an idea, but breaking into maybe big asset owners who are, we've always done it that way. We know if we do this, it's predictable. We know we can manage the risks. Here is someone with some disruptive technology or a new technique or new material. Oh dear, how do we use that? And if we go, here is a tsunami of huge processes and procedures that you have to go through before we'll speak to you, even at a commercial level. That's a nonsense. I'd like to see us approaching this as not every idea that's brought to us is a great one, but we should reach out, we should explore.
Mm.
We should say, we're going to try this out. I don't care that this company hasn't got £2 million worth of insurances against some impossible risk. We will manage that. But the benefit to us is that we're taking asset management forward. We're not just stuck in a kind of time warp of we've always done it this way.
Yeah.
Be curious.
Yeah. And how have you thought about how that would work? Would it be like an incubator model? Because you see sort of things like that around renewable technology, for example.
Yes.
Yeah.
And you see it in many of the other new industries that they wouldn't prosper if they didn't innovate.
Mm-hmm.
So in my world, it's saying, okay, the first time we try this out, we will be with the people doing it. It will be a heavy presence from us. We will manage risks on their behalf because they're not used to our environment. We will take ownership of this.
Yeah.
We'll take responsibility for it because if it works, the prize is worth it.
Mm.
We don't just sit passively behind a desk saying, oh, they're different. Oh, this is a bit dodgy.
Mm.
Go out there and help people.
Mm.
I think if I can build a little bit on what
please.
Andrew's saying, because I think it's really important. I think there are a number of dilemmas that people responsible for managing infrastructure face, and one of them is that recurs, and Andrew will have encountered this many times, I'm sure, is that we're generally talking here about really long life assets,
Mm-hmm.
and when someone tries to introduce a new technology, a new technique, new material, whatever, it's inevitable that the question will be asked, well, what's the track record?
Yes.
Because if you're going to use something and you want it to be there for tens of years, then you kind of want confidence that it's going to last that long.
Mm.
Well, when you've got something new, you are just not going to have that data set to be able to say, well, I can show you that it's worked really well in this environment for the last however long.
Mm.
So there will always be an element of risk when you're introducing something new, particularly around longevity. But as Andrew says, if we're not prepared to take that risk in a managed way, we just don't achieve progress.
Yes, absolutely.
Could you imagine when the first time fire was invented, people go, oh, what's its track record?
Yeah.
Does it meet our safety case? I'm not sure. Sorry.
Presumably it wouldn't have done. Yeah. Where would we be? Where would we be today without fire? I didn't realise we were going to go that far back, actually.
Sorry, it's my Eric Cantona moment.
Oh, yes. Eric Cantona moment. We remember that. So it was something about seagulls, wasn't it?
Yeah.
Anyway, that brings us to our sort of esoteric question that we always ask on this podcast. If you each had the power to change just one thing right now to create a positive impact in this space, what would it be and why? Who wants to go? Oh, Steve,
I'm happy
you go first.
I'm happy to. And look, I'm going to repeat myself a little bit, because I think that if I was able to change one thing, it would be to stop taking our aging infrastructure for granted.
Yes.
And the reason why is that if we were to stop doing that, then we would recognize the value of all of the work that those responsible for those assets do today. We would value more the role of engineers. We would value much more the role of the men and women who are out maintaining and renewing our infrastructure. And there are some really shocking statistics around actually the amount of abuse, for example, that road workers face. There are increasing incidents, for example, of people entering traffic management zones, sometimes by mistake, but sometimes willfully, which just shows a lack of respect of what's being done and compromising the safety of people. And I think that if we could get to that point where we cease to take these things for granted, actually the consequence of that is that we would be celebrating those people, not castigating them. And one thing that I think is really clear is that if we don't value this, then we are going to face a skills and capacity crisis that will only serve to compound the challenges that we have got. Because one of the things, actually, Andrew, that we haven't talked about is just how vital it is when there is going to be increasing demand for skills, capacity, capability to look after our aging infrastructure, that we need to make sure that doing work in this area feels like a really exciting and purposeful thing to do. And I've talked about the fact that professionally, I think it's absolutely fascinating, but really, in engineering, what greater purpose is there than to return to where I started, to spend time making sure that that core hardwiring of our society and our economy continues to function. That is a very high purpose. But because we take things for granted, we don't value it adequately. And I think people don't necessarily therefore feel as drawn into working in what I think is a really exciting and important area.
Yeah, there's a real profile, a bit of profile work to be done there,
For
PR
sure.
job to be done there.
Yeah.
That's very, very interesting. Yeah.
I agree with Steve completely. The starting point is profile at all levels. We as senior, I think senior or old or aging engineers have a huge responsibility in all levels, all stages of people's career, to make the case for the much more challenging and ultimately satisfying roles of engineers in looking after infrastructure, as distinct from just building new stuff. But we need to take that case outside the engineering fishbowl, into government. There's a role for our engineering institutions, because putting it out there, constantly reinforcing the scale of the challenge, the satisfaction of meeting that challenge, but the consequences of not meeting that challenge. We are quite weak on that at the moment.
Yes.
I mean, this podcast is a nice sort of counter to that, but we need far, far more emphasis on this at all levels of society, including in the engineering profession.
Yes. Very well said. And I think we're out of time, but that was really, really fascinating insight, and you've covered a lot of ground, as I would expect from you two, actually. But thank you for giving us so much to think about and so much to act on. So that's all we have time for, I'm afraid, on this episode of Positive Impact. A huge thank you to our guests, Steve Denton and Professor Andrew McNaughton, for such a thoughtful and open conversation. Now, if you enjoyed this episode, don't forget to subscribe, rate and share. You can find more information and resources in the episode description. Thanks for listening, and join us again next time as we continue exploring ideas that shape a smarter, greener future. I'm Lucy Siegle, and this is Positive Impact. Goodbye.